Let's look at the IP packet delivery process. A host will first send a packet to its default gateway. The packet will then be placed in the frame. If you notice, we're dealing with the network and the data link portions of the OSI model. So we are actually sending data to the default gateway, which is usually our closest router. This is how we're going to be delivering data to a remote network. The packet itself will be placed into a frame at the data link layer, and this will then be passed across the physical layer where a router in between will receive the frame. The router will use its route table to choose the next hop towards the destination. It will find the destination in the table, choose the next hop, and then identify what the MAC address of the next hop is. Notice that this happens at layer 3. Routers run the IP protocol in the same way as the IP hosts run the IP protocol. And in fact, an IP host has the same intelligence as a router, but a router will typically have a bit more capability. It will be able to run routing protocols, and it will do things at just a little bit more optimal level than a PC. Finally, once the MAC address of the next hop is determined, the packet will be placed in a frame. It will then repeat steps 2 through 7 as necessary to get all of the packets towards the destination. Once the final router receives the frame, the router will find the network to which it is directly connected. The MAC address of the end host is determined by using ARP, and finally the packet is placed in a frame to the final destination. What we notice here is that all the while, from the original transmission of the data through every router and every ARP process, we never have to cover anything above layer 3. Layer 4 is not even contacted until the final destination is reached, and only at that point will any data that is placed inside of a frame for the destination application ever be passed above layer 3. And that's a very important aspect of the packet delivery process.